Welcome to this video. We have been going over this practice AP Precalculus exam given by the College Board, the multiple choice portion, the no calculator portion, actually, to be specific, and we left off on number 16. So let's begin from here. The figure shows a circle centered at the origin with an angle of measure theta radians in standard position. The terminal ray of the angle intersects the circle at point P, and point R also lies on the circle. The coordinates of P are x, y, and the coordinates of R are x, negative y, which the following is true about the sine of theta. Okay, so it basically asking you what the value is in terms of x or y, and then there's some reasoning for it. Okay, so maybe let's try to find the value of sine theta directly without even going through the choices here. Okay, so if this point has coordinates x, y, and this has x minus y, don't get confused that we know this is in the negative x-axis, but why do they say it's x? Well, it's just a variable name, so you can call it even a, b, a minus b. Okay, they just denoted it as x. Don't get it confused with the x-axis type of x. Okay, this x is just a number, and it's actually this x would be a negative number actually, but we don't really care about that. Okay, so hopefully I didn't even confuse you even more, but I'm just trying to say that this x is just some number. They're noting it as a variable x. Don't get it confused with, we know that the actual x coordinate is negative. All right, anyway, so we're trying to find sine of theta. Okay, so if this is our theta, remember we can take a reference angle even. Usually it's like over here. This is the theta reference. Okay, so if we take sine of theta reference, it would be, so this would be x, okay? And then this would be our y, so sine, so would be like that. Okay, and then actually they give us this point as 5, 0. Okay, so probably need to use this, okay? So this guy, this circle has a radius of 5. This length is 5. This is also the radius. So x squared of x squared plus y squared is equal to 5 actually. Okay, so sine of theta would be, so opposite of this theta reference, which is x, and then we divide by the hypotenuse, which is 5. So theta ref, let's say, is this, okay? Now, to get sine theta, we have to consider the sign. So this is the sign, so meaning plus or minus. That type of sign, not this trig function sign, okay? Oh, my bad. Actually, this is x, this is y. My bad. So this would be y over 5. Okay? I want to correct that myself. I'm like, looking, it doesn't look quite right, actually. So, y is this axis, right? Okay. Yeah. So, sine theta reference is y over 5, okay? So, at this point here, our y is positive. So we just leave it as positive. So let me rewrite this y. Okay? So it would be sine theta is y over 5. Okay? And that is the right answer, but let's look at the reasoning. Because it is the ratio of the vertical displacement of P from the x-axis to the distance between the origin and P. Okay? So vertical displacement of P from the x-axis. Vertical displacement just means it's the distance from the x-axis. That's y exactly. And then to the distance between the origin and P. Origin and P, that's the radius that we're seeing, which is 5. So that's correct. That's D. Hopefully that made sense. To recap one more time, they told us this is x comma y. We want sine of theta, so we're going to take theta reference over here. Okay, and what's sine of theta reference? It's y opposite over hypotenuse, which is 5. So that's our answer. Function f is given by 3x squared plus 2x plus 1. The graph of which the following functions is the image of the graph of f after a vertical dilation of the graph by a factor of 2. So vertical dilation, that means we are going to stretch it. I really don't like how they teach the as dilation. I learned it as stretch and compress. That's more intuitive to me versus dilation. Okay? Dilation only means to expand. Okay? So when we want to vertical dilate it or to stretch it by a factor of 2, it would be 2f of x. As simple as that. So what's 2f of x? We're going to multiply 2 to each one then. So it'll be 6x squared plus 4x plus 2. And that's choice B. Okay? And this even has the reasoning, which you can read yourself. Okay, table of values for the functions f and g at selected values of x are given here. Functions f and g are defined for all real numbers. Let h be the function defined by h is f of g of x. What is the value of h of 0? This is just testing composite function. Again, this is the second time in this exam. Okay, so h of 0 would be f of g of 0. So f of, what's g of 0? G of 0 is 1, so now we just find what's f of 1. That is negative 2. Function f and g are defined for all real numbers such that g of x is f of 2 times x minus 4, which is the following sequences of transformations maps the graph of f to the graph of g in the same x, y plane. Okay, so here we see that it's shifted. Okay, and it's to the right by 4. And I said in a previous video, when it's minus, that means it's shift to the right. If it's plus, it's shift to the left. Okay, and then here would be so they're using the term dilation again, which I don't like. When we have this here, when this is greater, or usually it's like, I learned it as, if it's like 1 over a x minus b, something like that. If a, so only, let's just assume a is positive, okay? If it's negative, then this just be a reflection, so let's assume a is positive. If a is greater than 1, then we say that it's a stretch. We're going to stretch it out, or expand it horizontally. Stretch, I like to think of it as stretch. When a is less than 1, but it's positive, so greater than 0, we're going to compress it. Okay? So here, it is less, a is less than 1, because a would be half in this case. 1 over half is 2. So it is compressed, or how they call it is dilated. It's dilated by half. Okay, so let's see which choice it is. Dilated by half looks like it's one of these two. And horizontal translation of the graph by, so I don't get the point of this problem. Translation by minus 4 units, it should be D then. So I would think it's more intuitive and more useful if you know if it's shifted to the right or left, but instead of just saying horizontal translation by 4 units. What does that mean? To which direction? You can probably guess which direction, because in the positive x direction, it'll be plus 4 by 4 units. But anyway, enough of me complaining about whoever wrote this exam. Okay, so this is how you would solve this. Okay, 20, the graph the figure shows the graph of a trigonometric function f, which the following could be an expression for f of x. Okay, so we probably need to find like the amplitude and the phase shift and all that stuff, which, yeah, okay? Amplitude would be here, phase shift would be this term over here. Okay, and this is just vertical shifting, and this is, again, dilation, if you want to call it, or stretch, compress type of thing. Okay, so since we already see it's all of them are shifted down by 1, hopefully you can see that. For example, if the amplitude, so if you shift it back up by 1, we can see that the peak to peak would be from -3 to 3. So we can see the amplitude is 3 also. And that's given for all of them, so that doesn't help us that much actually. Now, we just want to know if it's cosine or sine and how much is shifted probably. Okay, so actually maybe a good technique is maybe we can just plug in some numbers to see if it matches what we have up here. Okay, and we should plug in easy numbers, okay? For example, let's plug in x is pi over 4 into a and c to see if we can eliminate even one of them. Okay, this might not be the quickest way. I'm solving this live like I would in an exam, but I'm just showing you things that I think of. Okay, instead of doing it the long way of actually figuring out which is the sine, cosine, how much is shifted and all that. Okay, so if we plug in x is pi over 4, then let me just even write it out. It'll be 3 cosine of, well, pi over 4 minus pi over 4 is 0, so 2 times 0 is 0. So cosine is 0 minus 1, which is 3 minus 1, which is 2. Do we get 2 at x is pi over 4? It would be pi over, this is pi over 2, right? So pi over 4 would be over here. It's minus 1. So it clearly is not a. Okay? And we can do similar for c. It'll be 3 sine of 0 minus 1, which is minus 1. Sine of 0 is 1. By the way, I don't know if I said this earlier. Cosine of 0 is 1. Oh, sine of 0 is 0, sorry. So I'm getting confused by these two because I wanted to explain this. Okay, so let me finish explaining this. Sine of 0 is 0, so it'll be 0 minus 1, which is negative 1. Okay? I don't know if I said this here. Cosine of 0 is 1, so 3 times 1 is 3 minus 1. So that's why I got that. Okay? So it is minus 1 there. So let's keep that. Okay? Now let's also plug in maybe pi over 8 into these two to see if we can eliminate one of them. Okay, so let's do like, yeah, let's plug in pi over 8. So it'll be 3 cosine of 0 minus 1, which is again 2, same as up there. And pi over 8 over here will be 3 sine of 0 minus 1, which is negative 1, same as here. Exactly. So that's why I picked those points, pi over 4 for these two and pi over 8 for these two, because it's easy to calculate. Okay, so at pi over 8, so that's this tick mark over here, is it 2? Clearly it's not, so eliminate here. Is it minus 1? Clearly it's not, eliminate that. Answer is C. So that's the quick way to do this, probably. Instead of figuring out each one of them, how to shift them. Sine and cosine are different. They're actually, we typically say that cosine is earlier by pi over 2 and all that. So this is probably the quick way to do it. Okay? Last problem for this video. And then I'll call it apart. So let me change things up a bit. Hopefully this has been helpful so far. If it has, please like this video. And please subscribe also to show your support and all that. All right, so let's finish off with this problem in this video. Let f be a rational function that is graphed in the xy plane. Consider x is 1 and x is 7. The polynomial in the numerator of f has a 0 at x is 1 and does not have a 0 at x is 7. The polynomial in the denominator has zeros at both x is 1 and x is 7. The multiplicities of the zeros at x is 1 in the numerator and in the denominator are equal, which the following statements is true. So this is saying if there's a 0 at x is 1, that means there needs to be x minus 1 on the top. Okay? Does not have a 0 at x is 7. So nothing goes, there's no x minus 7 at the top, okay? The polynomial in the denominator has zeros at both x is 1 and x is 7. So x minus 1, x minus 7. We write it like that. The multiplicities of the zeros x is 1 in the numerator and in the denominator are equal. So this is equal. So let's make it the simplest case, which the following statements is true. So let's say f is this, okay? Well, we see that there's a vertical asymptote at x is 7, and there's a hole or removable discontinuity at x is 1. So let's see which choice it is. Holes at both x is 1 and 7. No, this x is 7 is a vertical asymptote. No, it's a hole at x is 1. Hole at x is 1. Vertical asymptote at x is 7. That's the case. Vertical asymptote at both x is 1 and 7. No, there's a hole at x is 1. So, answer C. Okay, so that's it for this video. Once again, please like this video if you found it helpful in any way. And hopefully I see you in the next video where I solve the next few problems.